All right, welcome to TKLMS Academy, and we are on the topic solving linear inequalities. We're going to solve question 3. Now, this question 3 is super important, very important on how you get the set notation, and it requires so much of attention so that you do not make mistakes. So, in this particular video, we shall be solving question 3, A, B, D, and G. And I'll allow you to solve, try your hands on the remaining. Let's delve right into it. So, for the first question, okay, that's for A. We have 3 into brackets x minus 2 greater than x minus 4. And we have 4x plus 12 greater than 2x plus 17. So I want you to understand that these are two different inequalities. I'll be solving them separately, and then we'll try to see if there's a link between the two of them, and see if there's no link, we may have to look for how to join it together with a union or something like that. So here's what we do. For the first one on the left, we have 3x. So we're going to open the brackets. So we have 3x, 3 times 2, we have 6, greater than x minus 4. Next thing is you collect like terms. So 3x minus x, right, greater than negative 4 plus 6. Okay, if you simplify this, you're going to have 2x is greater than negative 4 plus 6, that's 2. Alright, so at this point, you divide both sides by 2, we're going to have x is greater than 1. Okay, so move on to the one on the right. We have collect like terms, so 4x minus 2x is greater than, we have 17 minus 12. Okay, collected like terms, 4x minus 2x, that's 2x, and then greater than 17 minus 12, that's 5. We're going to divide both sides by 2. Okay, we're going to have x is greater than 5 divided by 2, that gives us 2.5. Good. So we want to find out the set notation, how we can possibly, if there's a link between it. Now, if you say x is greater than 1, what are the values that are greater than 1? Of course, we have 2, 3, 4, and so on and so forth. When we consider the numbers that are greater than, on the right, we have x is greater than 2.5. What are the values that are greater than 2.5? Of course, if you are considering the integers, you start from 3, 4, 5, and so on and so forth. So you realize that the values on the left are a bit similar to the one on the right, only that 2 is not inclusive. Alright, 2 is not inclusive. So it means that the relationship between them starts from 3, 4, 5, and so on and so forth. So 2 is out of it. So the set notation we can give is x, such that the values of x are greater than 2.5. I hope you understand what I'm saying here. Okay, that is the set notation that you can give to this particular question. So you're not going to start from x is greater than 1, because the next number there, 2, is not common here. It's not common there. Rather, from 3, it's common. So I'm sure you may be asking, why can't you then write x is greater than 3? No, it won't be that. Because if you say it's greater than 3, that means that 3 is going to be out of it. Okay, so we're going to start from x is greater than 2.5. I hope you get this. Okay, so let's move on to the second one. Very, very interesting set of questions. So let's see. That's for B, 3B. That's 2x minus 5 less than x minus 1, and 7 into bracket x plus 1 greater than 23 minus x. So let's solve this. we have 2x. So we are solving b right now. 2x minus 5 less than x minus 1. Okay, and then we have 7 into brackets x plus 1 greater than 23 minus x. So in order to solve this, now let's start with the left. To collect the like terms, we have 2x minus x, okay, less than negative 1 plus 5. By the way, if you don't understand how we're moving the terms, how the negative is turning to positive, you may just want to watch some of the earlier videos. Okay, so 2x minus x, we have x here. I mean, it means 2x minus 1x. Okay, and then negative 1 plus 5, that gives us 4. And then we move on to the equation on the right hand side. We're going to open the bracket, that will be 7x plus 7, okay, and then greater than 2x minus, oh, that's not 2x, that's 23. 23 minus x. So we're going to collect the like terms, collect the ones that have x. So that will be 7x plus x greater than 23 minus 7. So 7x plus x, that leaves us with 8x. Then 23 minus 7, that leaves us with 16. Okay, then next thing is we're going to divide both sides by 8. That's going to leave us with x is greater than 2. Okay, so in this particular case, x is less than 4. So what are the values that are less than 4? Of course, we start from 3, 2, 1, and so on and so forth. Okay. Then look at this other one. We have x is greater than 2. What are the numbers that are greater than 2? We start from 3, 4, 5, and so on and so forth. Now, by the time you look at the two range of values, the two values, what do we have common? 3 is common. 3 is common to the two of them. You understand? So what you can do is, now there are two ways by which you can do this. You can just say there's something common in between them, then you can first do this. Now take note of this. You can either first draw a number line or write it in such a way that you're going to have, you have x less than 4. You could decide to write it such that you have, if x is less than 4, that means that 4 is greater than x. So you can say 4 is greater than x. Okay, so what I want to do here is that I want to merge the two inequalities because there's something common. There's something common. Okay, so 4 is greater than x. Then I'm writing it in such a way that I'm going to have x to be in between the two of them. So I have 4 is greater than x here, and I have x is greater than 2. Okay, so now I can say 4 is greater than x and x is greater than 2. So this is a relationship between them. That is a relationship between them. How you can write this is you could decide to make the 2 come first and then the 4 come last. So just like you are turning the whole thing the other way around, you can become 2, okay, is less than x and x is less than 4. Okay, that's another way you can look at it. You are still going to be absolutely correct. And if you want to use the number line, so anyone you choose. Now, so in this case, we are saying the answer is x, such that then you can write this. Or if you don't want to write that, you can write this. Any of the two goes. So x such that I want to write the second one. So x is less than x and x is less than 4. That is the answer to this question. Okay, let's jump into the next question, which is D. We have 15 minus x and blah blah. Let's look at it quickly. So um, we have it as 15 minus x less than 2 into bracket 11 minus x. Okay, and then we have 5 into bracket 3x minus 1. Okay, we have greater than 12x plus 19. So let's move to the left. So we are solving question D right now. So we have 15 minus x is less than, open the brackets, that will be 22 minus 2x. Next, you're going to collect the like terms. So um, let's move the ones that have x to the left. So we're going to have minus x plus 2x, okay, less than 22 minus 15. So negative x, that's negative 1x plus 2x, that gives us with x, okay, less than 22 minus 15, okay, 22 minus 15, that leaves us with 7. Okay, so here we have x is less than 7. That is what you should have on the left hand side. On the right hand side, you have 5 times 3, that's 15x. Okay, 5 times 1, we have 5, greater than 12x plus 19. Okay, correct like terms, we have 15x minus 12x greater than 19 plus 5. Okay, so 15x minus 12x, that leaves us with 3x greater than 19 plus 5. We're going to have 24. So we're going to divide both sides by 3. We're going to have x is greater than 8. Okay, so here we have x is less than 7. So in this particular case, this is going to be a little bit different from the ones we've done. So take a study, you need to study it carefully and look at the various ways you can arrive at your answer. So if x is less than 7, we are looking at 6, 5, 4, and so on and so forth. And then if x is greater than 8, we are looking at 9, 10, 11, and so on and so forth. So we can see there's nothing that is similar. I mean, there's nothing that is common. There's nothing that is common between these two. So, in one word, the answer to this question is that there's no value. No value is common. There's no step notation that you can use to describe these two. That's the answer simply. Another way you can look at it is you can draw the number line and see what you're going to get. Okay, so let's say this is 0. Okay, let me not start the 0 from there because, so let's say this is 0 here, this is 7, and this is 8. Okay, this is 8. Then you have your 1, 2, 3, and so on and so forth there. Now let's say this is our 7. Now when we say that x is less than 7, that means that here is 7, we are going to the left because it's less than 7. And then x is greater than 8. So you can draw a circle of 8 and you move to the right. As you can see, they are moving opposite each other. So there's nothing that is common. This is another way by which you can easily, get and understand this question. So in this question, no values. There's nothing that is similar there. Okay, we make progress. And then we move on to G, which is 4 into bracket 3x plus 7 less or equals to 20, or 2 into bracket 3x minus 5 greater or equals to 7 minus 6x 2. Now, do not be scared about the fraction that you have there. So let's jump right into it. Alright, so we have 4 into brackets 3x plus 7, okay, and then we have less or equals to 20, or, let me write the 20 well, or you have 2 into bracket 3x minus 5 greater than or equals to 7 minus 6x over 2. So how do we do this? Let's start from the left. We open the bracket. So 4 times 3, we have 12x. Okay, 4 times 7, we have 28, less or equals to 20. Let's retain the 12, the one that has x on the left. So we will have 20 minus 28. We have 12x, 20 minus 28, that gives us negative 8. Okay, and then the next thing is we divide both sides by 12. We're going to have x less or equals to negative 8 over 12. Okay, so we're going to have x as negative. We're going to take it to the simplest form. That's 4 will go into this, 2, and then 3. Simple, as simple as that. So move on to the equation on the right. We have 2 times 3, that's 6x. 2 times 5, we have 10. Greater or equals to, we still have our 7 over 6x over 2, everything over 2. So how do you get rid of the division divided by 2? You multiply all through by 2. So we're going to have 2 into bracket 6x minus 10 greater or equals to 2 into bracket 7 minus 6x over 2. So 2 takes out 2. We are left with 2 times 6 is 12x minus 20 greater or equals to 7 minus 6x. And then collect the like terms. What do we have? We have 12x plus 6x greater or equals to 7 plus 20. So we have 18x greater or equals to 27 here. Okay, then you divide both sides by 18. You have x greater or equals to 27 over 18. Okay, then of course 9 will comfortably take this, so that will be 3 and that will be 2. So we have x is greater or equals to 3 over 2. Okay, cool. Now want to find the set notation for this. Now this is not difficult. One way you can do it is consider x is less or equals to negative 2 over 3. You can quickly sketch your number line. This is 1. This is negative 1 on the left hand side there. So your negative 2 over 3 is before you get to 1, somewhere around here. So you shade the circle and the side is less than, so meaning it goes to the left. Okay, and then we have the other one, which is we have 0 here. Now this is more like 1.5 or 1 over 1 over 2. Okay, so if this is 1, this is 2, 1.5 is somewhere around here. Okay, so you're going to shade the inside of this, shade the inside of this. Now it says x is greater than, so it goes to the right. It goes to the right. So if you look at this as well, it's more like there's no real relationship between them. You understand? There's no real relationship between them. So maybe the best, I mean, there's no, you can't combine them. So the values are separate. They are separate. Like I said, no values in between them. The values are separate. So you can write like this, like x such that x, okay, is less or equals to 2 to negative 2 over 3. With then you now write the other part, which is x is greater or equals to 3 over 2. This, you can write it this way. Okay, you can write it this way. So also the one that we did previously where we wrote there's no values, which is correct, no real values in between them. So if you like, you can also have it and say x is less than 7. Okay, then union x is greater than 8. Okay, so that is the set notation that you can use. All right, so thank you very much. We want you to watch out for our next video, which is going to be on how you sketch the graph of linear inequalities. Bye.